This video will briefly cover the AISC bending moment philosophy for use in rolled steel beams. As you know, there are two basic design philosophies that steel uses: the allowable strength design method, or ASD, and the load and resistance factor design method, called LRFD. ASD can basically be described as the design capacity, or the design bending moment capacity of our beam must be greater than or equal to the required moment capacity, sometimes referred to as the allowable moment capacity. This is shown in the slide as Mn divided by omega greater than or equal to Ma. The load and resistance factor design philosophy can basically be described in the same manner. That is, the design bending moment capacity of our beam must be greater than or equal to the required moment capacity of the beam. Sometimes in LRFD this is called the factored moment capacity. Again, as you can see in the slide, this can be represented by the notation phi Mn must be greater than or equal to M sub u. The required moment for allowable strength design, or ASD, as we mentioned previously, is labeled as M sub A. This could be given to you in a problem, or you might have to calculate it from the load combinations. Similarly, in LRFD, the design moment capacity has to be greater than the required moment, which is referred to as M sub u. This again could be given to you in a problem, or you might have to calculate it from the load combinations. These are the same load combinations that you've seen previously with other types of behavior, whether that be tension member or compression member design. The difference between ASD and LRFD largely revolves around the use of a safety factor in ASD and a resistance factor in LRFD. For bending moment behavior or flexural behavior, the safety factor that ASD uses is always equal to 1.67. When using LRFD in bending or flexural behavior, the resistance factor, phi, is always 0.9. The nominal moment capacity, Mn, will be calculated from different formulas, which we'll see here in subsequent videos. The thing to remember about the nominal moment capacity is it is the same whether you are using ASD or LRFD philosophy. We only have to calculate 1 Mn no matter which philosophy we are using.